Hello students, welcome to Legacy IAS Academy. Today we are going to discuss about a weather event that has been making the headlines from past few weeks is regarding the triple dip La Nina. And in this particular video we are going to discuss in details what do we understand by the term La Nina, what basically is the triple dip La Nina, and why triple dip La Nina is occurring right now, and what is its significance as far as the weather conditions in India is concerned, or even the weather conditions at the global level. So first of all, let us try to understand why this particular this weather event is in news. So the ongoing La Nina phase of the equatorial Pacific Ocean is expected, or as has been predicted by the scientists from National Ocean and Atmospheric Studies of USA, that is going to persist for at least another 6 months. If we talk about the La Nina, it is believed to be that after this 6 month period, next 6 month period, this particular La Nina event is going to become one of the longest ever La Nina episode that has been recorded in the history. And for this particular period, if we talk about this particular century or last century, it is also only the third episode since 1950s to stretch into a third year. That means generally we talk about La Nina does not extend more than 1 or 1.5 years, but this particular time it is expected to extend into its third year. And due to this extended period of La Nina event, it is going to have a wide-ranging implications from this weather event, and all across the world we can see a lot of changes in the weather pattern, a lot of changes in the rainfall and temperature distribution pattern, which can potentially aggravate both floods in certain part of the region or droughts in certain part of the world. So that is overall the introduction about the La Nina and the triple dip La Nina. So let us first try to understand that what is basically La Nina. So La Nina is a term that basically used to refer to a phase of ENSO, where ENSO stands for El Nino and Southern Oscillation. What is El Nino and Southern Oscillation? We'll discuss in a while. But for now, we can just understand that La Nina refers to that phase of El Nino and Southern Oscillation, where the sea surface temperatures, especially in the Eastern Pacific Ocean, become cooler than the normal temperature. And when the same similar phase, when we have the increase in the temperature or the sea surface temperature becomes higher, its sea surface become warmer in nature, the same event is called as El Nino. So basically El Nino and La Nina are on the opposite side of extreme of ENSO phenomena. So the warmer phase where sea surface temperature is higher than normal, as we discussed, is called as El Nino, and as a result of interactions that we see between the oceanic movement of the oceanic water movement as well as the wind system, both El Nino and La Nina have almost opposite impact on the weather event. For example, even with if we talk from the respect or perspective of India, the La Nina on the other hand is responsible for a strengthening of the monsoon, a strengthening of monsoon, a stronger monsoon. That means heavier than average rainfall. On the other hand, if we talk about El Nino is generally associated with weaker monsoon and drought-like conditions or dry conditions in the Indian subcontinent. So, as we have discussed that El Nino and La Nina both are two distinct and opposite phases of an phenomena that is called as ENSO, that stands for El Nino and Southern Oscillation. So, let us try to understand that what and how these conditions develop. So basically, ENSO refers to a phenomena that occurs in the Pacific Ocean around the equatorial region, and basically it is a change or difference in temperature between the Eastern Pacific, Central Pacific, and the Western Pacific. So as far as the normal conditions are concerned, we have an atmospheric circulation that occurs around the Pacific Ocean and which also extends to the nearby Indian as well as Atlantic Ocean. So as far as the neutral conditions are concerned, so first of all, what we can see from this particular diagram, that during normal time or during neutral time, we have a high temperature near the oceanic area, just slightly to the north of Australia, and we have relatively lower temperature in the central part of the Pacific, and again we have relatively higher temperature on the Atlantic Ocean, and again we have low temperature over Indian Ocean, and then we have high temperature over the Eastern Africa. So this is the variation of temperature that we generally observe during the normal times. So as we know that if there is high temperature, what happens? The air will become warmer, and as the air becomes warmer, they start to rise up in the upward direction. And as the air start to rise up, they carry large amount of moisture along with themselves. This moisture start to undergo condensation that further leads to formation of clouds that finally yields into precipitation or rainfall. So during normal times, what we'll expect? We'll expect heavy rainfall and cloud formation just to the north of Australia around equatorial Pacific. We'll expect similar kind of a small amount of rainfall and cloud formation for the Eastern African region, and we'll also expect cloud formation and rainfall around the North Atlantic Ocean. However, what happens? The places where we have low temperature, in those regions, the sea surface temperature will be sea surface will be colder, and the air will become drier because the rate of evaporation will obviously be low. So as the air becomes drier, it becomes colder, it becomes heavier, and thus air start to sink down. And sinking of the air mass basically uh, prohibit any kind of cloud formation and rainfall. So in these particular regions, we'll expect a dry season, while in these particular region, we'll expect the rainfall. So during again neutral time, we can expect that around East African continent will have rainfall, around northern Australia will have heavy rainfall, and around North Atlantic Ocean will also have rainfall. While on the western coast of North America, as well as around Indian Ocean, like an Arabian Peninsula such as India, Arabian Peninsula, here will have a kind of dry condition. So this is the time of normal conditions. Now, what happened due to some unknown or we can say unexplained reason, these situations undergo change, and the first phase or the first variant of this ENSO phase is something that we referred as El Nino. Now, what we can see is happening in El Nino. Here, the green water represents cold water, while the yellow water represents the warm water. So during this time, what happens? The temperature of Central Pacific becomes very higher, while temperatures both in the Eastern Pacific as well as in the Western Pacific become relatively lower. So due to this, what happens? Now we have the rise of warm air that happens around Central Pacific, and thus will have rainfall around this area. On the other hand, if you look at this area such as we can say near South America, since air mass is sinking here, so this condition will result to dry conditions of weather here. Similarly, here air mass is sinking, so around China, Japan, and Philippines island will also have dry conditions. On the other hand, we'll have heavy rainfall over East Africa, and now as we can see in the Indian Ocean, we can see the temperature of Indian Ocean has become higher. So if the temperature of Indian Ocean becomes higher, that means the pressure will become low. And if the pressure becomes low, the monsoon wind, which generally moves from the Indian Ocean toward Indian subcontinent, they will lose the energy. They will not have sufficient pressure gradient. They will not have sufficient pressure difference between Indian Ocean and Indian subcontinent to move through. And thus, during that time, in India will have a weak monsoon and less rainfall. And that is why we are saying that El Nino is associated with a weaker than usual monsoon or lower than usual rainfall as far as the Indian subcontinent is concerned. While at the same time, El Nino can cause significant flooding in the East Africa and significant flooding in the western part of North America and basically United States of America. Now, on the other extreme, we have the phenomena that we are going to discuss is La Nina. So in La Nina, what basically happened, as we again can see from the temperature distribution diagram, now in La Nina, we have higher than average temperature around northern Pacific, just to the north of Australia. Then we have colder temperature or colder sea surface temperature near South America as well as the North America. And similarly, over Indian Ocean also we can see we have colder than usual water or sea surface temperature. So in these circumstances, what happens? Obviously, the area where we have highest temperature, that is to the north of Australia, we have significant upward movement of the warm air, and thus in this region we can expect heavy rainfall. On the other hand, here since the air is descending around the western coast of United States of America, what we can expect since the air mass is descending, obviously it will create a dry condition. So here we'll have a drought-like conditions that may prevail here. On the other hand, during El Nino and normal phase of the ENSO phenomena, the air mass was ascending near East Africa. But during La Nina, what we are seeing is that air mass start to descend over the East African continent, and thus obviously what will happen here also will have a dry conditions or drought-like situations that will develop here. Now, what about India? So, as we know that India receives most of its rainfall from the southwesterly monsoon, and the southwesterly monsoon winds blow from Indian Ocean toward the Indian subcontinent. However, this strength of the wind depends upon what is the pressure gradient between the Indian subcontinent and the Indian Ocean. And the pressure gradient is directly dependent upon the temperature gradient. So basically what is happening is that during La Nina phase, we have colder than usual water in the Indian Ocean, and water is colder than usual. That means obviously we can expect there will be a more high pressure or higher than normal pressure will develop over the Indian Ocean. And since the high pressure area is strengthening over Indian Ocean, this will push more strongly the monsoon winds toward the Indian subcontinent. So obviously what we'll expect, that whenever we have La Nina like condition, we can expect a stronger monsoon, we can expect normal rainfall or even higher than normal rainfall. So that is the kind of situation that we can expect during La Nina. We have drought-like situations around the western coast of North America. We have drought-like situations in the East Africa, while we have heavy rainfall both in Indian subcontinent as well as around Indonesia, Australia, Philippines, and all the way up to Japan. And overall, we can say East Asia. So this is how the three different phases of ENSO, El Nino and Southern Oscillation, the neutral phase, El Nino phase, and La Nina phase affect weather conditions differently in different part of the world. So in ENSO, we have discussed a term that is EN, that stands for El Nino. So why we are using this term Southern Oscillation? What basically is the Southern Oscillation? So Southern Oscillation is nothing but it refers to the pressure variation between the eastern and western part of Pacific. For example, we have discussed during El Nino, we have different temperature gradient in different part of Pacific. In La Nina, this temperature gradient changes. So that is why we have also change in pressure. So it seems that between El Nino phase and La Nina phase, the pressure keeps on fluctuating. Like sometimes we have high pressure over Eastern Pacific and low pressure over Western Pacific. Sometimes we have the reverse situation. So this change of pressure or seesaw pattern of pressure variation is something that is referred as Southern Oscillation. Now we have discussed La Nina. So what basically is a triple dip La Nina? So triple dip La Nina refers to such situations where the period of La Nina extend for more than 2.5 and 3 years. If you talk about the usual episodes of La Nina weather event, it extends normally for 9 months all the way up to 1 year to a max. However, similarly for the El Nino as well, both El Nino and La Nina can maximum extend from 9 months to 1 year. However, recently in year 2015-16, we have an event that is referred by climatologists as Godzilla El Nino. Why it is called as Godzilla El Nino? Because this weather event extended for more than 18 to 20 months. Similarly, right now what our world today is facing is an extended period of La Nina event where it began somewhere in September 2020, and it is expected that this particular La Nina event is going to occur, or we can say is expected to run all the way up to March 2023. So such a huge period of La Nina event is something that is called as triple dip. Triple dip because it has extended for 3 years. 1 year, that is September 2020, then we have 2021, then 2022, and then finally we have 2023. Also, if we talk about the strength of La Nina, it is weakest during September, October, and becomes strongest during the March, April season. Now, obviously, why we are talking about triple dip La Nina? Is it a very rare kind of occurrences? So obviously the answer is yes. This is on the diagram. You can see we have the different years corresponding to El Nino and La Nina, where La Nina is represented by a blue picture. So as you can see, if we have mostly if we talk about data from 1950s till now, we have only 3 times when the La Nina has extended over more than 3 years or up to 3 years. One was during 1973 to 1976, second was during 1998 to 2001, and third phase which we are testing right now is 2020 to 2023. Same stands for El Nino as well. However, we have not seen a single instance when El Nino has extended for over more than 2 years. The maximum strength of El Nino that we have observed is up to 2 years. For example, in 70s, in 57, 59, and 2014 to 16, the Godzilla El Nino that we have just right now discussed. So obviously, this is a very rare phenomena because in last 70 years it has happened only 3 times. However, what makes this particular instance of La Nina much more peculiar or much more distinct is that in last 2 times, that means between 73 to 76 and 98 to 2001, when we have last triple dip La Nina, that time it was preceded by a very strong El Nino phenomena. So during El Nino, what is happening? The water surface temperature, the surface temperature of the sea is rising very much. So if El Nino preceding El Nino is stronger, that means obviously we can expect that La Nina will go on for longer duration of time because it will take a longer period of time for the water to return back to its normal temperature. However, what makes this particular La Nina unique is that preceding El Nino event was a normal event. There was not very strong warming of the sea surface, and that is why it does not make any sense, or the scientists are not able to exactly pinpoint that why it is taking so a long time period for the water temperature to come back to the normal. So that is what makes this particular La Nina event much more unique in the sense. However, some scientists believe that it can be attributed to the event of global warming, where overall, despite El Nino occurring strongly or not, the global temperature especially sea surface temperature is continuously rising. So that might be one reason. So what is going to be the likely impact of this triple dip La Nina? So just we have discussed right now that it can cause a strong and above average monsoon in the preceding year, in this particular year, and obviously we can expect that in the next following years as well, as these 3 years have been corresponding with the La Nina event, we can expect higher than average monsoon rainfall. For example, this year itself, India has received more than 7% of a long period average rainfall over its territory. Similarly, as we discussed, due to the events of La Nina, we have drought-like situation because we have dry weather that prevails in the United States, especially the southern and western coasts of United States, as well as the Horn of Africa. Horn of Africa is basically a region located in the eastern coast of Africa, and Horn of Africa is made up of 4 countries, that is Somalia, Ethiopia, and we have Eritrea and Djibouti. And similarly, on the other hand, it can cause significant flooding in Australia, Indonesia, and Pakistan. Current flooding situation that is going on in Pakistan, Pakistan is facing one of its worst flood disaster in recent history. So that can also be attributed to the La Nina like event that has been extending for such a significant period of time. Now coming to again look at briefly that how weather situations will be affected by this La Nina. So obviously USA face a dry weather, then we'll have South America, the northern part of South America will face wet weather, heavy rainfall. On whole this Australian subcontinent, the Southeast Asia, East Asia, they will be face a heavy rainfall like situation, so we'll have a wet situation here. In India we'll have a kind of wet situation, heavy rainfall because of La Nina. Similarly, the Eastern Africa will have dry weather. The Pakistan and this Iran region will have a dry weather in the January to May period. While if we talk about Madagascar and the southern region of Africa, they will have a wet weather. So this is kind of brief overview of how weather situation will change or how weather situation will develop in the coming months as La Nina is extending. So the question comes that whether there is a some strong relationship between ENSO and climate change. So first of all, scientists are not able to clearly identify the relationship or establish the relations because they say that we have a basic lack of understanding of natural variability of ENSO. Now, natural variability of ENSO means that why we can see that sometime El Nino phenomena occurs after 2 years, sometimes it does not occur for 5 years, sometimes it takes more than 7 years for ENSO to for El Nino phenomena to occur. So why this huge variation is there in the occurrences of El Nino and La Nina is still a mystery. So that is why we do not know this and we cannot establish that how it is related to global warming. However, some scientists do believe that the global warming has exacerbated the crisis of El Nino and La Nina by increasing the frequency and intensity of such weather phenomena, such weather events. However, in conclusion, what we can say, there is no clear evidences of linkages with the global warming as far as the La Nina or triple dip La Nina is concerned. On the other hand, we have a scientist from World Meteorological Organization. Upon continuous studies, what they have found and tried to explain the relation between La Nina and global warming in this particular manner. So, as we know, what is La Nina? La Nina is a situation when we have colder than normal sea surface temperature in the Eastern Pacific. So, due to this cold sea surface temperature, what happens? The water is able, this oceanic water is able to absorb more and more heat from the atmosphere. So if oceanic water is able to absorb more and more heat from the atmosphere, that means the atmospheric temperature will obviously decline because there is a strong heat transfer that occurs between atmospheric part of the earth as well as the oceanic part of the earth. So due to more and more heat being absorbed by the ocean, we'll have lower atmospheric temperature. And this lower atmospheric temperature can lead to cooling of the atmosphere. And what is the problem that our world currently facing is the global warming. That means we are due to the continuous release of greenhouse gases, the atmospheric temperature is continuously increasing. So what we can say that as La Nina will create cold sea surface temperature, the cold sea surface will absorb more heat, and the absorption of more heat can cause lowering of atmospheric temperature, and thus La Nina can be expected to counter the effects of global warming. However, we have to be cautious here because again a report published by WMO has clearly stated that whatever cooling is happening due to La Nina is not enough to reverse or even neutralize the impacts of global warming. Its cooling influence can be at best can be seen to be temporary in nature, and it can temporarily slow the rise of global temperature, but on the long term basis, if you talk about on the decadal basis or even on the century basis, it will not halt or reverse the long term warming trend. So just depending, we cannot say that La Nina will tackle the problem of global warming or tackle the crisis, environmental crisis that our world is facing today. So that is all about this particular issue. I hope you understood the concept of El Nino, La Nina, triple dip La Nina, and its wider ramifications all across the world. Thank you very much.